Hey everybody, Mr. Bowman here. This video we're going to go through 1.10 multivariate data. We're going to look at mainly the achieved response, and what we're going to do is as we go through it, we'll talk about what we could have done to improve it to a merit or an excellence response. So let's get straight into it. So the task, or what will happen is you'll have a task that will be given to you and you'll be given some data as well. So we've got both of these on the screen currently. Let's read through the task first. You have been provided with some data regarding New Zealand and Samoan rugby players. Specifically, it's been from the Rugby World Cup 2015. In this task, you've been asked to investigate whether there is a relationship between each team and the weight of their respective players. So we've got team and weight. So they've told us what we're investigating here. In the real internal, you'll have to pick some of these. And what's super important is every internal will do this. They'll be really clear. They'll say, for this task, the population is, and I'll be able to copy and paste this information every time I need to refer back to the population. That way, I don't have to get creative with my wording and accidentally stuff up here and there. So when I start these internals, my first point is just jotting down some key notes. So I want to start off with, what is my numeric variable? I also want to mention what's my categorical variable. Forgive me if my spelling's wrong for any of these. And I also need to mention what my population is. And again, that one is a copy and paste job. So my number variable, remember we're comparing the weight and the teams. The weight is going to be the number from these two measurements, and that's measured in kilograms. And the category will be the team itself, and that will either be from New Zealand or Samoa. And once you've got this in mind, you can kind of start seeing the box and whiskers come together. So, because what we're going to have is we're going to have two box and whiskers. Just making up an example here. And the first one might be NZ rugby players, and the second one might be Samoan rugby players. And along the x-axis, that will be the weight of these players. So you can kind of see, just from this first little bit, we can see what the box and whiskers going to be looking like. And finally, the last thing is, I always like to have this ready for me. I'm just going to copy and paste that population. So Control C, let's paste it in here, Control V, and we're going to need reference to that later on. So if you're looking for achieved, what we're going to need to do is we're going to need to think about the problem and plan section first. And the very first thing you need to do is you need to write out your problem statement. And if you remember, that is something that goes, I wonder if, and then we run along from there. So let's complete that for our question. So I wonder if, we're comparing the median weight, because that's our number variable. So I wonder if the median weight of, let's pick our first group, New Zealand rugby players. Rugby players is larger, or sorry, rather tends to be larger. That last bit, there's a couple things that's important. Tends to be is really important. We've got to use that exact language. And larger, that's the direction. So again, that's something we need to use. So tends to be larger than and we're going to repeat, I may as well copy and paste that bit there that we talked about for New Zealand rugby players. I need the exact same statement, but for Samoan rugby players. So let's copy that. So Control C, Control V, median weight of, and let's get rid of New Zealand and write Samoan rugby players. And a lot of us, unfortunately, are going to finish here in error, but we have not done yet because we need to have the population in. And let's go for, and at this stage here, I'm going to copy and paste my population for, Control C, all New Zealand and Samoan rugby players from the Rugby World Cup 2015. And I got a full stop. So that wraps up the problem section. So it's pulling together all that information to get the right places. So we're going to carry on with the achieved element for this. The next part you need to do for achieved is, following PPDAC, we've got problem plan, which we've done. D stands for data. So we need the data section coming up next. And the data section in this case here is your is your graph. So I'm going to write IE graph, and we're going to use NZ Grapher to help us with that. So when you're looking for the graph, the first thing is we're going to jump over to this side of the screen for our data. We need to select all the data. Your computer, you may have to, highlight and then drag down for everything, or if you're lucky, if you go Control A, that will select all the data, and then we can go Control C, and that means I've copied all the data in. Once you've copied your data, you're going to need to open up NZ Grapher. I had it opened up already, and we're going to click the blue box opening. We're going to go Data. Oh, I think I've clicked the wrong thing there. We're going to go Data, Paste Table, and what we're going to go is we're going to go Control V. And you'll see all the data you copied has now been entered into this area here. And we click Import, and you'll see all your data has been uploaded on the right-hand side, or left-hand side rather. So what I'm going to do is I'm just going to maximize this. That way we can see the graph in a bit more detail. The first step that we're going to do here, we're going to select the graph type, which is down the bottom. We click About, and we're going to select the graph we want. The graph we want depends on what you're trying to do, but we're looking for box and whiskers, which are up here. And it also creates a dot plot for us, which is really cool. So let's click into dot plot. The numerical data, that's what we talked about in our Word document. If we go back, our number data was the weight in kilos, and our category data was the team. So we need to select this on NZ Grapher. So number data was the weight, and the category data was the team. And at the moment, we've only got the dot plot side of it, so we don't have a lot of information yet. And that's when we scroll off down to the middle and the bottom here. There's a lot of things we can check just to make our graph look a bit fancier. So the first thing we want to check, we want the box and whisker graphs, and we're going to click High Box Plot. So I've clicked that, and you'll see the two box plots have come up, which is awesome. I'm also going to click Summaries, which is the very top one. And you'll see these red bits of data have come up. These are really useful for later on because they've got the minimums, the lower quartiles, medians, mean, upper quartile, maximums, standard deviation, we didn't learn too much about that, and number, which is the sample size. So we've got everything here. The next thing we want to do, probably the two things I'm not liking, graph title is the default one, so we need to change that. And down the bottom, we've got weight, but the weight doesn't really tell us what kilos is. Well, what unit is that? Is it tons, kilograms, grams? So we need to be a bit more specific. So the easiest one to update for is weight. So we go weight, and then in brackets, we're going to write kilograms. And once you've got that, if you click Update Graph down the bottom right, I've done that just now, you'll see it's now been updated. The next thing is the title. That was the one up the top. And I'm just going to say something really simple. Comparing New Zealand and Samoan rugby player weights from RWC 15. So I've used a bit of an abbreviation. I've spelled that wrong. Rugby World Cup 15. There we go. So I then click Update, and look, now my title has been edited. So that's really cool. So at this stage here, I've got everything I need. Just to run through, we need the heading. We need the units down the x-axis. We need our two red summary statistics. And we need our box plots. If you've got all those, you're on the right track. So we're now going to right click, and we're going to go copy image. So back to my Word document that I had open before, I'm now going to, in my data section, I'm going to go paste. And okay, so I've now got my graph here. I had to pause and make sure it worked properly. So we've now got the graph. Awesome. So that's the next achieve criteria. So just to recap, we've got the problem written, and I've got my graph. Following this, the next step we need to do is we need to analyze that graph. We need to get some meaning out of it. So let's put a new heading, analysis. And in the analysis section, you need 2 comparative statements to get achieved. So you need 2 of those, but I'm going to encourage us to do 3 just in case we get one wrong. So we're going to talk about the median. We're going to talk about the IQR, which is the interquartile range, and then we're going to talk about the shape. So we'll do 3 of these on the off chance that we get one of them wrong by mistake. So zooming up, we can see we've got the medians up here, MED, and then MED. So that's 108.5 and then 103. So let's just jot that down. I've moved the graph by mistake. Pop that back. So for NZ, the median was 108.5 kilos. For Samoa, the median was 103 kilos. So I'm going to expand on this later on. I'm just getting the key bits of information in there. Same thing again. Let's do the interquartile ranges for the New Zealand rugby players. I should note the interquartile range is the upper quartile, which you'll see UQ, and then minus the lower quartile, which is LQ. So we've got 116 minus 94.5. So just putting that in my calculator now, and I'm getting 21.5 for my New Zealand interquartile range. 21.5. Don't forget, these are still kilograms. And then the Samoan one down the bottom, we see UQ 112, LQ 93. Again, in my calculator, 112 minus 93. That's 19 kilograms. So let's scroll down. And then we got Samoan 19 kilograms. And then the shape is the last one. This is where we look at the dot plots for. So you'll see the dot plots and the box and whiskers for both graphs. I guess the key thing to see is we kind of see a group of data kind of in the middle of both things. So there's big clumps in the middle, and then there's a few values either side of it. So because there's a big group of data in the middle, that means they're both unimodal. So they're both unimodal. I then like to look for symmetry. And I normally look at the whisker part here. You can see the right-hand whisker for New Zealand is a little smaller than the left-hand one, and the same for Samoa. We've got the whisker over here is a little bit smaller than the whisker over here. So neither of them are symmetrical, I would say. And then because of these whiskers, that tends to mean both of them have a small or subtle left tail. So we're going to write both unsymmetrical, and both have slight left tails. Okay, so I've got my key information. I now need to convert this into my comparative statements, my statistical wording. So let's start off with the median stuff up here. So let's get rid of that. So I'm going to start off with by talking about the New Zealand median being 108.5 kilos. So I see that the New Zealand median weight of rugby players is, and I should note here actually, let's emphasize something. I'm trying to bold that. So from my sample. So just a reminder, this isn't all New Zealand rugby players. This is just the 48 that I've sampled part of this Rugby World Cup. So from my sample is 108.5 kilos. So full stop. So I've talked about the New Zealand number. I now need to talk about the Samoan number. So I'm basically going to do the same thing, except I'm going to change New Zealand to Samoa, and I need to update 108.5 to 103. So let's go Control C. No point typing it out completely. And as I said, New Zealand needs to change because that's now going to be the Samoan players. And the median itself has changed. So that's going to be 103 kilos. So I've now stated the two bits of information I pulled out from my graph. The only issue is I haven't got my comparative statements yet, and this is where the next line comes into play. So this means the New Zealand median weight is 5.5 kilograms larger than the Samoan median weight. And then again, from my sample. And this last statement here, it's comparative because I'm using the word larger. And I've also justified it. I've got a little bit into the merit stuff, even though it's easy, by using the numbers 5.5. And I got that from subtracting 108 minus 105. So that's all we need for the median. That easy. So 3 sentences, and I've got them all sorted. So let's delete this median stuff here. I now need to repeat this for my interquartile range, which is the second one that I want to look at. So let's get the key numbers down there. So starting that, I'm going to do the exact same thing. I may as well actually copy this sentence here. Control C, I'm going to go Control V, and I'm still comparing New Zealand, but this time around, I'm comparing the interquartile range. So I see the interquartile range of New Zealand rugby players. So let's get rid of this median weight of. From my sample is, and we're going to put in 21.5. I also see that the interquartile range of Samoan rugby players, and again, from my sample, is 19 kilograms. So I've got my two statements. I've stated what I saw regarding the New Zealand players. I stated what I saw regarding the Samoan players. So we're pretty good so far. I now need that comparative statement. So which one is larger and by how much? This means, so we're going to go 21.5. 21.5 minus 19. That's 2.5 larger for New Zealand. So I'll just write that down here so I don't forget that number. 2.5 kilograms larger. This means that the interquartile range of New Zealand rugby players from my sample, again just putting that in there just to be sure, is 2.5 kilograms larger than the interquartile range from Samoan rugby players. There we go. So we've done interquartile range and we've done the median. So just scooting on up to the other side of my page because we've gone down a little bit. So I can delete this interquartile range stuff we've got here. And then finally we need to talk about the shape. And we've got notes. This time around, the shape is actually fairly similar. So my comparative statement will be that they're both similar. But we still need to talk about what we saw. So I see that the distribution / shape of New Zealand rugby players, and again, Control B from my sample, is unimodal, because we saw that all the data was clumped together. They were unsymmetrical and had a slight left tail, wasn't it? Left tail. So that's what I saw from the New Zealand distribution. Luckily for me, the Samoan distribution was the exact same. So it's going to be the exact same sentence, except instead of saying New Zealand rugby players, we're going to be referring to the Samoan players. So let's go Control C, space, Control V, and there we go. Let's change this to Samoan rugby players. And I've now got my statement for what the Samoan player, the distribution looked like or the shape looked like. So I haven't done any comparison yet, so I haven't got my comparative statement, so let's do that. This means that the shape of New Zealand's, the shape of the distribution of weights for New Zealand and Samoan rugby players, again, Control B from my sample, is fairly similar. And there you go. That's my comparison. That word similar, I've compared them to note that they are the same. So let's get rid of all the stuff here. So just recapping what we've done so far, we've written the problem, and just noting this is the only stage where I've mentioned the population at this stage. Everything else I've referred to the sample because I'm referring to my graph, which is a sample of players. And then following below, I used NZ Grapher to do my box and whisker. I've then compared the medians. I've then below compared the interquartile range. And moving up to the top of the next page, I've now compared the shape. My final part of this, so if you think of PPDAC, I've done the problem plan, got the data done, I've done the analysis. C is the leftover thing. C stands for conclusion. And this is when we need to think about, well, is the median of New Zealand rugby players larger than the median of Samoan players in our population? We know in the sample it is, but is that the same for the population? So I'm just going to zoom up on my graph here. So to figure out if the medians are bigger in the population, we need to look on how many hits and how many misses we have. Hopefully you remember this in class. So starting at the New Zealand median, if I go down, it's pretty clear that I'm going to hit the Samoan middle 50%. There we go. So we've got a hit. And it was the same the other way around. I'm not sure why it zoomed in like that. That was a bit weird, I thought. Same thing around. If I go this way here, again, I've got a hit of the New Zealand one. So that means the middle 50% of New Zealand encapsulates the median of Samoan players. And the middle 50% of Samoan players captures the New Zealand players. So that means the medians are really close to each other. And I can't be confident that the median of one group is going to be bigger than the median of the other group. So let's exit the drawing part of it. So just to summarize, so we had 2 hits. That's the key bit of information that we needed, 2 hits. So let's talk about my sample first. So from my sample, so I'll put that in bold. The median weight of New Zealand rugby players, falls within the middle 50% of Samoan rugby players. So that was talking about the New Zealand hit. So when we went down, the New Zealand median hit the middle 50% of the Samoan players. So I then need to talk about the other way around, that the Samoan median hit the middle 50% of New Zealand players. Again, from my sample, the median weight of Samoan rugby players also falls within the middle 50% of the New Zealand rugby players. So that was both hits. So I've talked about the hit going down, I've talked about the hit going up. So we now need to explain what that means. So that means I don't have any evidence that the median of one group is going to be bigger than the median of the other group in New Zealand, because the medians are pretty close to each other. They may differ. So based on this, I do not have enough evidence to make a call that the median weight of New Zealand rugby players is larger than the median weight of Samoan rugby players for, and then over here we need to copy and paste the population that we talked about before. And I actually just realized there's a bit of a trick here. This part here, plus the population that I was going to include over there, this part here, I'm not sure if you've noticed, that's actually the exact same wording that I had over here. So if you look at the question, I wonder if the median weight tends to be larger than the median weight for all rugby players. So what I could actually do, instead of typing this out separately, I'm going to be a bit sneaky. I'm going to go Control C, and I'm going to scoot it on over here, and I'm going to get rid of what I did, and then I'm going to go Control V. So you'll see now I've got the median weight, and the key thing is I'm talking about the population now, which I've got reference to, so I don't have that evidence. And what this does here, this actually nearly wraps up our thing. The final thing I suggest we include is, let's include a bit of a comment about sampling variability, because the report we've done here is based on this graph over here. But if we had a different group of New Zealand players and Samoan players, whilst it's going to be pretty similar, the median may be slightly different. Maybe this maximum here will be slightly smaller, maybe it'll be slightly bigger, we're not sure. So that means everything we've talked about may change slightly if we had a different group of players. So let's communicate that. So from, I should note that the above, I've written that twice, the above analysis is dependent on the sample we have taken. If another sample was taken, the summary statistics, which is that red stuff, oh, I've written statistics first. The summary statistics and graphs may be slightly different. So that's just noting everything may be slightly different. But I just wanted to, I've forgotten the y and slightly. There we go. Might be slightly different. But given how close the medians were, I would actually be quite shocked if the answer would change. Because the medians in our sample were very close, I would not expect a different sample. Oops, a different sample of New Zealand and Samoan rugby players to have a different conclusion. And what that's saying is we're talking about the sample is probably going to have different statistics, but because the medians were really close, I don't think the conclusion we drew up here is going to change. But if it was close, maybe one median just narrowly hit the middle 50%, that might actually change the answer next time. But in this case, it doesn't. So what we've done here, just zooming out, we've done a full start to finish achieved level response. Hopefully this is a useful tool to help you out. If you're wondering, well, what I can do to improve my answer, maybe you're looking to get some merits and excellences, just a note on ways how to do that. In your problem section, you could talk about maybe you want to add in some background research. Maybe you want to add on a prediction, what you think the answer is going to be. And then that prediction should hopefully be justified with research as well. Okay, following on from that, if you're wanting to improve your analysis section, just a reminder, in your median discussion, you need to have support/evidence from your graph. And don't forget, that includes numbers. And we've actually started to do that by doing this 5.5 stuff. In addition to that, you might want to look at some background research that explains what you saw. Also, there might be some other variables that are impacting this observation. Just as an example, New Zealand, as I'm sure you're aware, is absolutely rugby mad, and it's quite a developed country. So what this might actually reflect, it might not actually reflect New Zealand and rugby players. It might just reflect the culture of rugby in New Zealand. Maybe we've got gyms everywhere. That means the rugby players can go to the gym more and they can put on more muscle. Maybe we've got extra nutritionists and extra kind of advice on how these players can be bigger and stronger. So maybe that's the only difference between the countries. Maybe it's nothing to do with New Zealand Samoa. Maybe it's just to reflect the resources that are available in New Zealand rugby. So there might be something else going on. Scrolling up to the top, same thing here. Again, supporting, if you want to get merit or excellence, supporting evidence in terms of numbers that come from the graph. And again, background research, there might be a reason for this. And then finally, there might be a reason why. Why is this the case? Or other variables going on here. As we talked about, the resources in New Zealand rugby might be a relevant one. And the last one here is shape. And this one here, I've got actually a specific point. I'm just going to copy and paste because it's the same thing for merit. You can talk about all of these and get them extra. But what you could do, this particular one, there's something called statistical insight, which sometimes changes answers slightly. So if we zoom up on our graph, if we have a look, this guy over here for Samoa, he's a 65 kilo rugby player. And you can see there's an extreme gap between him and the next player, which is over 80 kilos. So for me, this is actually probably an outlier, this gentleman. You'd suggest he's probably going to be a little halfback or something like that. But if I ignore this guy, the minimum is actually going to be over here, which means this part of the graph wouldn't exist. And we said before that it was a left tail, but now if I delete this part of the graph, it's actually a right tail, because that right-hand tail is now a lot larger than that left-hand tail. So that's quite interesting. That changes what we've got before. So that's something I'll talk about. I'll talk about if I remove this outlier, my shape for the Samoan graph is actually completely different. It's gone from a left tail to a right tail. And the New Zealand one, you can see there's a bit of a gap here as well. You can maybe make the same argument there. But the gap's not as big, so I'm more hesitant to do that one. But with Samoa, it's super clear cut. So let's go back to the other one over here. So statistical insight, removing Samoan outlier, and impact on your above analysis, because your above analysis is going to change if that outlier is removed. So there's a bit of statistical insight. Every graph will have something somewhere. It's just you spotting it and you thinking about how that's going to change your answers. So we've done that. The final part of our report is thinking about the conclusion. And we've actually done a little bit of it. This sampling variability discussion that we talked about and how it wasn't going to impact our conclusion, that's a little bit into the merit stuff already, which is cool. I guess the next thing we might want to talk about is we might want to talk about is our sample representative of our population? So that's the first thing to note. So are the people we've got here, are they representative of the population? So for example, maybe this was like a training game, like a game before the World Cup, and they had a lot of new players in there. So maybe these smaller values are younger people who haven't had as much time in the gym and haven't put on as much weight. So there's nothing to suggest that here, but that's just an example. So is it representative of the population? Because if it's not, our conclusion's rubbish. The next thing we could talk about the effect of other variables. And we've started talking about that here. It's not really just as straightforward as, oh yeah, New Zealand players look a little bit bigger than Samoan players, but it's too close to call, so we can't make a claim. Maybe there's something else going on, and I think New Zealand rugby infrastructure is very developed. New Zealand rugby certainly has a lot more money than Samoan rugby, so maybe it's just a financial thing or a rugby infrastructure type of thing impacting this result. So that there would be a good example of what to add on. Following that, we might want to consider the sample size. Small sample sizes can sometimes be a bit wild and unpredictable. Big sample sizes can sometimes be better. But did the sample size capture the variation that you'd expect to see in the population size? So did it capture the variation, or poor spelling now, variation you would expect to see in the population? And for example, in this case, you'd say it's probably a yes, because this is a Rugby World Cup. All your best players are going to make themselves available. So I think the players you get there would probably be, fairly representative of New Zealand and Samoan rugby players. Particularly at a World Cup level, certainly wouldn't be representative of all New Zealand and Samoan rugby players. If you go to like the local rugby club on a Saturday, those players are not going to be as big, they're not going to be as strong, so it certainly wouldn't represent them, just depending on what you're doing. And I guess the final thing we should start thinking about is just any other issues. And this is going to depend or change from group to group, but maybe in your background research you found something out and you want to discuss it a bit more. Maybe as I said before, maybe the hit is really, really close. For example, if the median narrowly hits, officially in this sample, we don't have any evidence to make a call, but the next sample, maybe that median is going to slightly miss. So that might be something that we want to talk about, and we can see a slight miss coming up there. So that is probably the last thing I'd think about adding on for these things here. And I guess, when I think about it, this bit here, we're talking about the middle 50% and the medians. You could, again, probably justify this with numbers. So you could compare the median versus the upper So you could do median versus the LQ and the upper quartile. That might be a good way to justify those in a bit more detail as well. So I guess the key thing is for merit, it's this justifying part. So it's this supporting evidence. It's justifying with numbers. That's what they're looking for merit. For excellence, they're looking for this statistical insight. It might be to do with the graphs and their impact. It might be about how robust your conclusion is. So here we're expecting the conclusion to be the same no matter what. It might be considering other variables that might impact the research we're looking at and the answers, or it might be some background research over here. And then we had some other comments about, is the sample being representative? Maybe. Is the sample size going to be good enough? And then just generically, every graph or study will have its own issues. Is there something else coming up? So that wraps up a quick video answer for this particular Rugby World Cup Samoa versus New Zealand players. Hopefully you found it useful. This would be a really good resource if you are doing the internal, maybe you're struggling to figure out what to write and when to write it. So thanks so much for watching. Now let's get into our real internal and heaps practice.